Good afternoon. I'm Mr. Toby. So I'm here to take you on stoichiometry of chemical reactions. Now, when we talk about stoichiometry, you must consider one thing, and that thing is mole. You must understand how mole can be represented in a chemical equation. For instance, if you look at this equation here on the board, you have calcium oxide reacting with carbon dioxide gas to give you calcium carbonate. Now, from what you can see here, you have 1 mole of calcium oxide reacting with 1 mole of carbon dioxide to give you 1 mole of calcium carbonate. Now you may want to ask that how is the 1 mole, how did it come about? Actually, you look at the coefficient of each of the species in the chemical reaction. The CaO here, the calcium oxide, just has 1 coefficient. The coefficient here is 1. The coefficient of carbon dioxide here is 1. The coefficient of calcium carbonate here is what? 1. So we call it 1 mole. So from the stoichiometry here, we have 1 mole of calcium oxide reacting with 1 mole of carbon dioxide to give you 1 mole of calcium carbonate. So the stoichiometry tells us about the ratio using the mole. So the ratio here becomes 1 ratio 1 ratio 1. That is the first step to take when calculating anything that has to do with stoichiometry. So from the definition on the board, we have it is a study of the quantitative relationship implied by chemical reaction. We are looking at quantity here. The quantity of calcium oxide here is 1 mole. The quantity of carbon dioxide here is 1 mole. Likewise, the quantity of calcium carbonate here is 1 mole. So I'm going to give you some problems in which you can use stoichiometry to solve. Now, on the board, you have a question in which we are told to calculate the volume of carbon dioxide. Now, calculate the volume of carbon dioxide produced when 30 grams of calcium carbonate 4 is heated. Now we have been given the equation. So what we're going to do here is this. What I tell students is you try as much as possible to mark 2 compounds that are needed. If you look at the chemical equation, we have 3 components, this, and this. But of the 3, 2 are required. And how do I know? The question says calculate the volume of carbon dioxide. So since carbon dioxide is what we are looking for, please, I will advise that you mark it out. That's the first step. Now, the next step is produced when 30 grams of calcium carbonate. The next one you have to mark will be the component of this chemical equation that has a value attached to it. And if you can see from the equation here, there is 30 grams attached to calcium carbonate. So you mark that one, calcium carbonate. So you can see from here that we have been able to mark out 2 components of this chemical equation that are required. Alright? So the next thing that we now need to do is to now translate what we have done so far. We translate what we have marked. Now we have marked calcium carbonate, we have also marked carbon dioxide. So you ask yourself, how many moles of calcium carbonate do I have here? How many moles of carbon dioxide do I have here? The answer is 1 mole each. So we now translate by writing 1 mole of calcium carbonate, right? Because I ticked it, so I have to write it out. Produced, how many moles of carbon dioxide do we have here? We have 1 mole. So we have 1 mole of carbon dioxide. You can see here now that I didn't mention calcium oxide because calcium oxide has got nothing to do with this problem. So these are the two I marked, hence I need to interpret them. So that is another step that we can take in solving this. So when we arrive at this, we'll ask ourselves, do we need to convert? Is there any need to convert this mole to grams, or mole to volume, or mole to anything at all? So when we get to this point, we ask ourselves, is there any need for conversion? How do you know if there is a need for conversion? Now let us look at the question again. It said calculate the volume of carbon dioxide. You see? So the carbon dioxide I have here is in mole and not in volume. So that means I need to convert this 1 mole of carbon dioxide to volume, to molar volume. You see? So I wouldn't leave it as 1 mole of carbon dioxide again. The reason is because the question is asking me to calculate the volume of carbon dioxide. So what I have written here is mole of carbon dioxide. So what do I do here? There is need for us to convert to molar volume because we have been asked to calculate the volume of carbon dioxide. So what we do here now is to change this 1 mole of carbon dioxide into the molar volume. And what is the molar volume of a gas? It's given in the bracket there. Molar volume of a gas at STP is 22.4 dm³. So I come here, instead of writing 1 mole of carbon dioxide, what I will do is to write 22.4 dm³ of carbon dioxide. So I have converted. Now, do I need to convert 1 mole of calcium trioxocarbonate? Well, the question will determine that. Now, when you look at the question, you see that 30 grams, is attached to calcium trioxocarbonate. The calcium trioxocarbonate there is in grams. So what I just need to do here is to convert the 1 mole of calcium trioxocarbonate into what you call the mass. All right? So how do you calculate calcium? How do you convert 1 mole of calcium trioxocarbonate to mass? It's very simple. Calcium trioxocarbonate is calcium, Ca, C, and O3. Ca is 40. So 40 plus C is 12 plus 16 times 3. When you add everything together, you're going to get 100. So that means you have 100 grams of calcium trioxocarbonate. You can see why it is very necessary to convert. So your conversion is based on what you have in the question. So we are almost there. So from what I have here now, we have 100 grams of calcium trioxocarbonate yielding to 2.4 dm³ of carbon dioxide according to this equation. According to this equation, if you heat 100 grams of calcium trioxocarbonate, you are going to get 22.4 dm³ of carbon dioxide according to this equation. But what about according to the question? The question is requiring 30 grams of calcium trioxocarbonate. So what is the volume of carbon dioxide that 30 grams of calcium trioxocarbonate will yield? You now come here and write, therefore, 30 grams of calcium trioxocarbonate will yield what volume of carbon dioxide? We don't know. Let's use X dm³. Right? So the X is to be solved for. So how do we solve it? We can use cross multiplication from the knowledge of our mathematics. This 30 should multiply this, then equals to 100 times X. Alright? So 30 times 22.4 equals to 100x. 100 times x gives you 100x. 30 times 22.4 gives you the answer here. So what we do now is we make x the subject of formula by dividing both sides by 100. Divide both sides by 100. Alright? 100 cancel 100, and you are left with x here. X equals to, now this cancels this. Then we now have 3 times 22.4. This will be 2.24 times 3. This will give you 4 times 3 is 12, 2 carry 1, 3 times 2 is 7.6. So we have 6.72. Our x is 6.72 dnq. 6.72 dnq. So therefore x is equals to 6.72 dnq of carbon dioxide gas. So that is how we solve anything that has to do with stoichiometry. The first thing you need to do, understand the question, and once the question is understood, try and mark out the 2 components that are needed. And I told you before that how did you know the components to be ticked? You look at what you are looking for. For instance, here we are looking for carbon dioxide. You look for carbon dioxide. So you look for carbon dioxide in the equation, and you tick. Alright? Then followed by the components too that has a value attached to it. So calcium transcarbonate has a value attached to it. So you mark. After marking, you should be able to know the most of those components that you have marked. For instance, here I have 1 mole of this and 1 mole of this. So you do that. Then followed by your conversion. What determines your conversion is your question. And I hope I've really passed that information across. Thank you very much.